Hello, Matt with LeanStacks here, back with another technology education episode. This is an episode in our development operations series where we're going to talk about creating an AMI, or an Amazon Machine Image. An Amazon Machine Image is a server template that you create from an EC2 instance in your AWS account. As you can see, I've logged into the LeanStacks AWS account and I'm looking at the EC2 dashboard. I'm going to click on the Instances page, and as you can see, here's instance named EV001, which we've been using in previous LeanStacks development operations episodes. If you haven't yet seen the episodes in this series, I encourage you to watch them. In those episodes, we learned how to launch an instance, which we launched at instance EV001. Then we learned how to SSH to the instance. We learned how to use SCP to copy files to the instance. And then we copied the Oracle Java SE runtime environment to our EV001 EC2 instance and installed Java on it. So this instance is now not only the base Amazon Linux operating system or server template, but it also includes the latest version of Oracle's Java properly installed on the server with the Java_home environment variable registered. So now what we want to do, we've configured essentially a Linux Java application server, and we want to create a server template, or AMI as it's called in Amazon Web Services, from this EC2 instance so that we can use that AMI to provision as many distinct EC2 Java application servers as we want within our account. So let's get started creating an AMI. Notice that my EC2 instance is in a stopped state. This is very important. If the EC2 instance for which you wish to create an AMI is currently running, you're going to want to stop it. So the prerequisite steps that you should follow before creating an AMI is, if the instance is running, go ahead and prepare that instance. Install any packages that you wish to have installed, clean up any logs, make sure that any Linux services are either in a started or stopped state as you desire them to be when a new instance is going to be launched from the AMI that you create from this instance. So if you've installed certain Linux services or packages that run as Linux services on this EC2 instance, and you want those services to be in a running state whenever a new EC2 instance of this type is launched, then you'll want to make sure that those services are enabled on the current server or EC2 instance before you take a snapshot or create an AMI from it. Likewise, if you want to clean up any logs, you should do so at this time before you create the AMI from this server. I have already done that on EC2 instance EV001. I've installed Java. I've made sure that I went to the var logs directory, looked for any old logs that would contain meaningless data on a new EC2 instance launched from this AMI we're about to create. I've removed those files, and I've cleaned up, for example, the Java Runtime Edition tar gunzip file. We didn't need that anymore. It was just taking up space on the disk for this server. So I've removed all those files that are unnecessary, and then I stopped the instance. So it's very important to stop the instance before you create an AMI. This obviously stops the disk, but it makes sure that all of the data on the volumes for this disk, which is what we're going to create a snapshot of, that they're in a consistent state. If the server is running at the time you try to create an AMI, the process of creating an AMI takes a snapshot of the root volume and any other EBS volumes you have attached to the AMI. And if those volumes are running and the data is possibly changing on those volumes at the time you're trying to create a snapshot, there is no way to guarantee that that data is in a consistent and reliable state when that snapshot is created. You always want to stop your instance, or if your instance is running, AWS will prompt you for permission to stop the instance and restart it after the AMI is created. I have chosen to stop my instance. I always do that. I always separate it into two steps: stop the instance, create the AMI, and then when I'm ready, after I'm done creating the AMI, I can restart the instance if I need to use it. So to create an AMI, first you can see that in my account I do not have any AMIs yet at this time. So to create an AMI of the EV001 instance, select the Actions drop-down menu from the Instances page, and from the Image submenu, click Create Image. You only need to enter a few pieces of information. One, give it a unique image name. So this image name must be unique within your account. For me, I like to follow a naming standard so that when I come back, and if your organization creates a large number of images, have a naming standard for your images that allows you to quickly identify the image that you're searching for, especially if you're trying to launch new instances. You want to be able to clearly and reliably know that you are selecting the correct image to provision your EC2 instances from. So I'll call it T for template, AL for Amazon Linux, and Java because it's a Java application server. In my image description, I'm going to say a server template for Java applications. You can be very explicit within your image description, up to 255 characters, describing anything from the operating system of the template, maybe some characteristics about the packages that are installed, the operating system, the boot volume, things of that nature. So once you're done entering the name and description, and you've ensured that all of the volumes you wish to have included within this AMI are selected, you can click the Create Image button. That's all there is to it. AWS takes over. The process of creating the AMI has been started. We can click Close and go to the AMIs page. As you can see with the spinning icon, AWS is creating an image for us from our server. Essentially what's happening right now behind the scenes is AWS is capturing the information from our EV001 EC2 instance and copying the volumes that we selected to be a part of this AMI. It's making a copy of those to create the Amazon machine image or server template. Okay, as you can see, the creation of the Amazon machine image has completed. For this particular EC2 instance, it took about 3 to 5 minutes for AWS to create the AMI from our EC2 instance. Now the EC2 instance was really small. We only had an 8 gigabyte EBS volume attached to it, and that volume itself only was consuming around 1.5 to 2 gigabytes of the 8. So it did not take very long at all to create this particular AMI. You should keep in mind that the larger the EBS volume data is for the EC2 instance you're creating an AMI from, the longer it's going to take to create that AMI. It is truly the copying of the data that takes the most time when you're creating an AMI. So, as I mentioned before, creating an AMI, what happens is Amazon registers an Amazon machine image and all of the data attributes associated with that AMI, but it's associated with a snapshot. So if you click on your snapshots, what you'll see here is that a snapshot has been created at the same time. This is the time at my location as I'm filming right now. This snapshot was created, and it's the backing, it's the copy or the image that we just took of our EC2 instance. It has no tags applied to it, which is what we are about to do. So let's go ahead and do that. It's very important whenever you create any resource or data within AWS that you tag it, so that a day later, a week later, a month later, or even a year later, you can quickly identify and know what this resource or data is that has been created within your account. So let's apply a tag to this snapshot. I'm just going to apply the very minimal tag whose key is name, and I'm going to name it the same as my AMI image. So T for template, AL for Amazon Linux, and Java, meaning that it's a Java application server. I'll save the tag, and as you can see, my snapshot now has a name appearing in the name column of the table, and also the key value pair appears on the tags tab of the bottom panel. If I return to the AMIs tab, notice that it also does not have any tags applied to it. So let's apply the same name tag to the AMI. Great. So let's return to the Instances page and click the Launch Instance button. Now, once again, if you've watched the episode about how to launch an EC2 instance, you're familiar with these tabs on the side, which list the most popular and publicly available Amazon machine images you can use as the basis for your EC2 instance. When we launched the EV001 image, we selected this AMI, the Amazon Linux AMI, 64-bit AMI. And as you can see, there's AMIs here offered by AWS from a variety of operating systems. But now, when you click on the My AMIs tab, you see the AMI we just created is available for you, and you can select this AMI to serve as the basis for your EC2 instance. Amazon AMIs create a real power for your organization. You do not have to repetitively start by provisioning EC2 instances or your virtual servers from a base operating system image and then install the same set of packages onto that image before you can run your application on it. You can provision one. You can harden it from a security perspective, install all of the necessary foundation packages onto that virtual server or EC2 instance that your application requires, and then create an AMI from that and reuse it over and over and over. For instance, we can start with our Java AMI. We can use that to run command line based Java applications, but then we can further specialize this. We can install, say we have a suite of web applications that need to run in Apache Tomcat. We can start with our Java AMI, provision an EC2 instance from that, install and configure Apache Tomcat onto that, and create a new AMI that's a further specialization built for running web-based Java applications in Apache Tomcat. So there's a real power to AMIs. You should put some thought into What AMIs do you need? How many of them do you need? And then how to utilize them throughout your organization. I recommend not just using the AMI creation process as a way to create a point-in-time backup of your server. Put some real thought into how to come up with a structure behind your AMIs in your AWS account, and then you'll really get some efficiencies from having that suite of AMIs at your disposal. I hope you've enjoyed this episode. To watch more LeanStacks episodes, go to the LeanStacks YouTube channel. Haven't yet subscribed? Click the subscribe button below, and if you liked what you saw, click the thumbs up button below to let us know. Want more information? Go to LeanStacks.com. See you next time.